and welcome back to Schoolosophy. So in my previous video I gave a basic introduction to electrolysis, and in this video I am going to talk about the main rules which are needed for electrolysis. So let's start. In this video we are going to talk about rules of electrolysis. Now, as I explained in my previous video, electrolysis takes place for ionic compounds, and there are two types of ions present in the compounds. Cations or the positive ions and anions or the negative ions. So the rules of electrolysis are basically confined to these two types of ions. For cations, only metals or hydrogen forms at the positive electrode or at the cathode, because only these either metals or hydrogen form cations or positive ions. While anions, you have halides, which is nothing but chlorine, bromine, iodine, the whole group 7, or you will have sulfates or nitrates as anions. So let's look in detail first for anions. So for anions, there is only one major rule. At the positive electrode or the anode, only two types of anions can form. Either halides will form at the positive electrode or the anode, or you can have oxygen forming at the positive electrode or the anode. Now I'll explain how oxygen forms at the anode. For cations or for the negative electrode cathode, there are a few rules to follow. Either a metal will be formed or hydrogen will be formed. These are the only two types of cations which can form at the cathode. And here we'll see how to guess which one will form here. Okay, so let's first talk about what forms at the anode or the anions that form at the anode. When in a solution, the solution will either be concentrated or dilute. Now this is taken into consideration when it is concentrated when the solute is more, and it is dilute when the solute is less. So the more the solute particles, the concentrated the particular solution is. In a solution, when there is an halide, and if the solution is concentrated, then at the anode the halide will form. However, if the solution is dilute, even if it has halide in it, what will form at the anode is going to be oxygen. Now this will have an equation, and this I'll explain in detail further when I talk about half equations. Now the second case will be when either you have a sulfate or a nitrate as the anion. In that case, only oxygen will form at the anode. You'll find it confusing right now, but when we talk about examples, you'll understand what I'm talking about. And when in molten, if you have a halide as the anion, then obviously the halide will form. Or if you have any other like sulfate or nitrate, oxygen will form. So basically at the anode, only a halide or oxygen can form. Nothing else can form at the anode. To understand what will form at the cathode, the only important thing is the reactivity series. Now here I have the reactivity series written down for you, which starts with potassium and the last is apparently platinum, but you consider gold or platinum as the end. So to understand what forms at the cathode, only remember the less reactive metal or element will form at the cathode. Which means, now this is the reactivity series. This is the most reactive, while this, that is gold, is the least reactive. When you have to understand the reactivity series, you need to take into consideration H or hydrogen. So any element which is more reactive than hydrogen will not form when in a solution. So in a solution, you usually have the ionic compound which is mixed with water. Now water contains two ions. One is H+, that is hydrogen, and the second is OH-, which is hydroxide. So in a solution with the ionic compound, H+ and OH- ions will also be present. So here you need to realize that the less reactive element will form. If hydrogen is less reactive than the cation, then hydrogen will form at the cathode. However, if the cation is less reactive than hydrogen, then the cation will form. So then the metal will form. Let's take the example that copper is the cation present in the solution. Now copper is less reactive than hydrogen, so copper will form at the cathode. Another example could be that there is sodium hydroxide solution, which means that sodium is present in the solution with H plus and OH minus ions. Now sodium is more reactive than hydrogen. So the less reactive element will form. That means hydrogen will form at the cathode. This is the only thing you need to remember when talking about electrolysis or what element forms at the cathode. In a solution, H plus and OH minus ions are present, so the less reactive one will form at the cathode. However, when you talk about ionic compounds, when they are molten, only the ionic compounds are formed. So in this case, the cation, whichever cation is present, will form. This does sound confusing, but let me explain you with an example. Suppose you have potassium sulfate, you have a molten compound of potassium sulfate. Now potassium is more than hydrogen. However, it is a molten compound. So potassium will form at the cathode. And if it was the same thing in a solution, which means that we would have potassium sulfate in solution, then H plus ions would be present. And hydrogen is less reactive than potassium. So hydrogen will form at the cathode. Now also after examples you might find it confusing, but as soon as you do more practice about different solutions or molten compounds and electrolysis of these compounds, then you will understand better. That's it for this video. I hope you understood. If you have any doubts, please put in the comments down below. And if you want me to post a video on any topic, please put in the comments down below. So bye bye.